in this case, the electricity was carrying out the decomposition reaction. The decomposition of water, of course. Instead of electricity, we can also have sunlight. You'll see that you have AgCl. You keep it in sunlight, silver chloride. It forms Ag plus Cl2 gas. So what happens is that AgCl is white in color, and this is gray in color. So when you keep it in sunlight, the white color of the compound reactant will change to the gray color of silver. And this white, which turns to gray, this can be asked as a question also. Compound X is kept in sunlight. It is white in color. It gives a compound Y plus a gas G, where Y is gray in color. What is X, Y and G? Write the reaction. So after keeping in sunlight, if white turns to gray, it is nothing but AgCl changing to Ag and Cl2. And balance this reaction. Ag is balanced, Cl, you add a 2 over here. Again Ag has become 2, so you add a 2 over here. So this is your reaction of AgCl. You can also have AgBr reacting in the same way. And this is also the same. This is also white turning to gray. This is white, this is gray. So if you are asked white turning to gray, it can either be AgCl or AgBr. And an interesting thing is that this reaction and the Cl chlorine reaction both are used in photo development, in developing photos. So this is a very important reaction because it's used in developing your photographs. And in this reaction, the decomposition takes place by sunlight. And one thing, that the decomposition which takes place through heat is known as thermal decomposition. So there can be decomposition due to heat, due to sunlight, as well as by electricity. So they can ask you that also, how many types of decomposition, by what means can you decompose, can decomposition reaction takes place? So the answer is heat, sunlight and electricity. There are other methods also, but for the time being, we'll go into only these three. Then we come to the third type of reaction, which is displacement reactions. Now in displacement reactions, you have some A and a compound of an element B. Suppose mx, it's a salt, where m is the metal and x is the radical. And A will just knock this m out. It will become ax plus m. That means A will take the place of m in the salt, and m will just be knocked out and will be left alone. So an example for this is your iron plus CuSO4 will give FeSO4 plus Cu. So see, in this, iron has just knocked out copper. So it has formed ferrous sulfate and it has formed copper. You'll see they'll ask you questions like an iron nail was dipped in a copper sulfate solution. Now, a copper sulfate solution is blue in color. Now, when you dip this iron in this copper sulfate solution, this iron starts displacing the copper sulfate and it starts forming ferrous sulfate. And ferrous sulfate is green in color. So what happens is that as time passes, the bluish color of copper sulfate becomes paler and paler, and it finally changes to a light green color. And this copper, which is released, gets deposited on this iron nail. So the iron nail acquires a brownish color, a brownish coating, and that coating is of copper. So if they ask you that why does it, what do you observe when an iron nail is dipped in copper sulfate? So the observation is that the blue color of the copper sulfate starts disappearing, it becomes pale, and the iron nail gets a reddish brown coating which is of copper, and you need to give the reaction, and this is balanced.